computer. All right, so problem number 7. Let's do this. Go forward. All right, number 7. So it says f of x equals 1/2. Oh, wait. This isn't showing up. Sorry. There we go. That should look a little better. 1/2 x root x minus 2. And then outside we have plus 2. All right, so one of my kids from Elder One showing up. Asaf, you here? Asaf, you here?
Yeah, I'm here.
Yeah, you came to the wrong period. We have
all right.
We have periods 1, 2, 5, 6 today. 1, 2, 5, 6, and then 3, 4, 7, 8 in that order.
All right. Thank you.
See you tomorrow in class.
Yeah.
All right. First thing we want to kind of think about is let's think about what this would look like. This would basically look like this if I had graphed it. So that's what the parent function looks like. Okay. So let's take a look at a few things. This is going to go up 2. This is going to go right 2. And then this is going to make it graph in the y direction by a factor of 2, or by a factor of half. Okay, so it's not going to go as tall. Okay, so let's take this point right here. That point right there, I'm going to go right 2, and then I'm going to go up 2. This point here, I'm going to go right 2, and then I'm going to go up 2. So on 2, okay? But now I have to take into account, and then this point right here, I can go right 2, up 2. So what I need to take into account right now is this is my starting point. It's going to stay as is. Remember how this went up 2? Well, it's only going to go up 1 now. So it's actually like here. And then this one didn't go up, went up 2, not 4. So this is what my new graph is going to look like. So my domain of this starts at 2 and goes to infinity to the right. My range goes from positive 2 to infinity as well. So we go with this 2 and this 2. This is the domain 2. This is the range 2 that we're dealing with. So that's what our graph does. Does that help you?
Yes.
What else would you like to see, my friends, from the homework?
Can you go over 11B, please?
11B, yeah.
Yeah.
That's on the first page?
Yeah. Wait. Yeah.
Okay, so it says consider the location of the endpoint of the value of A carefully and identify the equation for a square root function that would neither have an x or a y intercept. Okay, all right, so this is 11B. Okay, we don't want our graph to have either an x or a y intercept. So let's think about this. So if we had a graph that did this, that wouldn't have an x or a y intercept. So how would we do that? Well, we would have to move it. We'd have to move it right. So x minus 3, and then we'd have to move it up. So this would move it right, and this would move it up, and that would never cross the x or the y axis. And that's just one of an infinite amount of answers you could have. So I'd say make sure you have something that is shifted to the right. So you'd have a subtraction under the radical, and make sure you have something that adds to it to be below it. Now, there's other things you could have done. I mean, obviously, if you made a graph that had done this, That means basically you would have a negative out front. That would work as well. So there's a lot of different iterations that would work on that problem. Anything else off of 11A?
Can you do, oh shoot, where is it? I just lost the page. Oh, can you do 13?
13. So is that the 12x to the 10th, y to the third? All that?
Yeah.
Okay. So number 13. Let's see, 12x to the 10. Y to the third. X to the -3, y to the 5th. All over 8x to the 5th. And then a y. Okay, first thing I want to take a look at is I'm going to take a look at all of these numbers. So that's going to basically give me 60 over 8. And then I'm going to reduce that. 4 will go into both. 4 goes to 16 15 times. 4 goes to 8 twice. So now I'm going to have 15 over 2 as my answer. So now we're going to kind of count. This would actually move down. So that means we would basically have x to the 8 on bottom if we included this. Does that make sense? If so, tug of war. X to the 10 on top, x to the 8 on the bottom, x to the 8th on bottom. Tug of war, top wins by 2. And then we'll do the same thing with the y's. I don't have any negative y values, so it looks like I have y to the 8 on top over y to the 1st on bottom. Tug of war, top wins by 7. And there's our answer. Anything else off of worksheet 8A? Okay, can I move to 8B? Okay, I'm looking at worksheet 8B almost now, just about now. It's opening up. It helps when I don't go to, oh shoot. Here we go, 8B. All right, what do you see on 8B that I could help you out with?
Can you do 1E?
1E. Okay, it says, let's consider other radical functions of higher index. Feel free to use your graphing calculator Desmos to see what the 5th root of x and the 4th root of x might look like. Make at least 2 statements about the shape to defend them. Okay. So this is 8E. So we're talking about even versus odd. Okay. When you have an even function, just traditionally, it's going to have a starting point and go forever. Okay, that would just be a basic. So if I had like the square root of x, that's what that would look like. No, I don't have an xy axis. But if I had the, say, the 3rd root of x, that's going to look like this. So if I had this starting point, some arbitrary starting point, let's call it smiley face, comma, frowny face for x and y. So the domain on this one would go from smiley face to infinity, and the range would go from frowny face to infinity. Whereas the domain and range of this one, when it's to an odd, will go negative to positive infinity. Okay, so if this is a 3, or if this is say 5th root, or 7th root, or 9th root, or 11th root, it's going to look kind of like a S being pulled out on the edges. Okay, if it's an even root, so if it's square root, 4th root, 6th root, it will have a starting point. So you'd have to justify how the domain and range are different. What else off of 8B would you like to talk about?
Can you go over 13?
13. describe the transformation one.
Yeah.
Okay. So let's take a look. Okay, so this is number 13. We have f of x equal to the third root of x. And then we have g at x equals square root x. So those are the two parent functions. So for letter A, it says, hey, what does f at x at negative x minus 4 do? Okay, so this goes down 4. And then if I plug a negative in here, this negative in here flips it over the y-axis. So some people might call it a vertical or a horizontal flip. Okay. And then let's see. For letter B, it says negative, like this. So that means, and we're still using the F. So this is going to go right 3. I take it back. It's going to go left 3. It's opposite. I'm so sorry. Left 3. And that's going to flip over the x-axis. Okay. Letter C. What does f at 2x do? Okay, so because this is inside, it's going to be 1 over 2, because what they use is 1 over a. Okay, so this is going to be a horizontal shrink. Okay, it's a shrink because it's half. Okay, if you had a fraction in here, it'd stretch it out. So what the horizontal thing is, what is it doing in the x direction? What's it going right and left? So like if you had a value, if you had 2 points, if one of the points happened, say here, and one of the points happened here on our original, and I know this is incorrect, what that 2 would do is this. This starting point would stay here, but then this point would move over to here because it would be at a half factor. Okay. Let's see, letter D. Letter D says we have f at, or 5 at negative x. Is that right? Am I looking at it right? Okay. So this 5 means you have a vertical stretch of factor 5. This negative inside flips it over the y-axis. So basically it does this. I don't know if you can see my thing. If we had a graph like this, the flip over does this. So it vertically flips. I'm sorry, I'm not going to flip this way to show you the vertical flip. Okay. And then the next one talks about what does g at negative x minus 4 do? So this moves down 4. This flips over the y-axis. So that is that one. And then I have negative g at x plus 3. So this is going to go left 3. And then this will flip over the x-axis. Okay, so notice where the negative falls to make it flip. And then we have g at 2x. Being that 2 is inside, is going to be a 1 over 2 horizontal. It's basically a horizontal compression of a factor of half. Or you multiply all of your x values by half. And then, oops, my screen just turned off. Oh, come on. I need my computers to stay on. And then the last one, g at negative x. That flips it over the y-axis. So it does all kinds of wonderful things. Any other questions for me, my friends? All right, if you would, get out a sheet of paper to take notes on. Tomorrow when you come to class, or Wednesday when you come to class, I'm actually going to give you a packet for a few days of notes, but I wanted to go over stuff. So y'all ready?
Yeah, buddy.
All right. Okay, so we're on the right one. Okay. Radicals is rational exponents, radical rules, and properties. Rewrite expressions from radical to rational exponent form and vice versa. Simplify by rationalizing the denominator. Simplify expressions with the application of the radical exponent rules. Add, subtract. Perfect. All right. So we have found square roots and cube roots. We can also find other roots. So you can have the nth root. You can have any number. In fact, you can get really gross and demented. You could have where this n is, you could put in some sort of equation in there, which is crazy. But what basically takes place with this type of scenario is if I had the nth root of x raised to the y power, I could rewrite this as x raised to the y divided by n. So we have then a fraction where the denominator is the root. Okay? So that's kind of the thing. And it goes backwards and forwards. So once you see a fraction, the denominator of your fraction becomes whatever the radical would have been. The square root of, the third root of, the fourth root of. Okay? So rewrite the expression using radical notation. So this is going to be the fifth root of 7 to the first, and it's done. This one is going to be the fourth root of 12 to the first, and it's done. We still doing okay? Then we want to rewrite these, having them as an exponent. So 27 is raised to the first power. So this is going to become 27 to the 1/6 power, and it's done. This 17 is raised to the first power, so this becomes 17 to the 1/3 power. And that's all you have to do is you're just converting from a radical to an exponent. May I move on? Okay. Let nth roots. Let n be the integer greater than 1 and a be the real number. If n is odd, so if this is an odd number, then you have infinite real roots. You can do the third root. Sorry about that. I can do the third root of any number. So positive or negative. So the third root of -8 is -2 because -2 times -2 times -2 is -8. Okay. So if you have this being an odd number, so 3, 5, 7, it's not going to be 1, but 3, 5, 7, etc. Then I can take the root of a negative or a positive. Okay. If it's even, so if I had the square root of 4, or if I had the fourth root of 2, 4, 8, 16, fourth root, though that's only has to be positive underneath the radical. Okay, so it only has a nth solutions. Okay, so you have to make sure these are positive in order for that to take place. If n is even and a equals 0, then it has 0 real roots, so that's just 0. And if n is even and as no real root. So this was basically saying if I add this as an even number and I add some number here, this has to be a positive number in order for me to do the root of it. Okay, if it was a negative number, I can't take the square root of negative 16. Yes, we understand it's 4i, but we want it to be a real component, not imaginary component. So when n is blank, let's see, I'm just going to move down the screen a little bit. Okay, so this is basically, I factored out the m comes outside. Power to power means I multiply the exponents together. I could rewrite that. I could rewrite this to be this. These are just the general form. If I had to raise to a negative exponent, that means it wants to move down. So if it moves down, it switches locations. It switches locations from top to bottom or bottom to top if it was in a fraction. Okay, and they're saying that, hey, a can't be equal to 0 because we can't divide by 0 because someone said that that's not right to do. All right, so rewrite the expression using radical notation. So this is x to the 2/7. So let me clean this up a little bit. Okay, so we want to have a radical in there. The only thing that's going to have a radical with it is the x. So the 3y is going to stay by itself, and I'm going to get the 7th root of x squared. Okay, and that's done. This problem, everything is going to be under the 5th root. And I'm going to have negative 4x to the 3rd. So that answer I feel is appropriate. Some people might want you to distribute that 3. So negative 4 times negative 4 times negative 4 is negative 64 x to the 3rd. I think both of these answers are appropriate. All I did here is I went negative 4 to the 3rd. So negative 4 times negative 4 times negative 4 to get negative 64. And then it says rewrite the expression using rational exponents. Okay, so everything is under the 4th root. So I'm going to get x to the 1/4 power, y to the 5/4 power, and it's done. And then this one is going to be negative a. I'll put that in parentheses because it's negative to the 2/3 power. The reason I put that negative a in parentheses is you're taking the 3rd root of negative a. So you want to have that grouped. Okay, so don't miss out on that. All right, how many identical factors are needed to find a square root, cube root, 4th root, 5th root? I don't know. Let's figure that out. All right, so we just want to simplify this. So I don't want to have a radical in the denominator. So this is basically saying the 4th root of 1 over the 4th root of 8. And the 4th root of 1 is 1 because 1 times 1 times 1 times 1 is 1. The 4th root of 8, I don't know. So I know that 2 times 2 times 2 is 8. So that's 3 of them. Times another 2 is 16. So if I multiply both the top and bottom by the 4th root of 2 and the 4th root of 2, I'm going to get on top 1 times the 4th root of 2 over the 4th root of 16. And the 4th root of 16 is 2 because 2 times 2 is 4 times 2 is 8 times 2 is 16. So this is going to give me an answer of the 4th root of 2 all over 2, and the problem is done. You can't reduce it any further. You don't have to keep the 1 out in front of the radical. Okay? So for problem number 10, I want x to the 5th to become a perfect 4th root. So I need to multiply both the top and the bottom by the 4th root of x to the 3rd. So 1 times the 4th root of x to the 3rd is just going to be 4th root of x to the 3rd on top. On bottom, if I combine these together, that's going to give me the 4th root of x to the 8th. 4 goes into 8 twice, so I wind up with x squared. There's no longer a radical there. Stop me if you have a question. For problem number 11, I might reduce this first. Give me 1 and 4. I'm going to multiply both top and bottom by root 15 and root 15 because I think that's the smallest thing. So that's going to give me root 45 over root 225. Square root of 225 is 15. I can break this up to 9 times 5. So the square root of 9 is 3, so I get 3 root 5. And then I have to remember to reduce. 3 and 15 reduce. So that gives me root 5 over 5.
Kaylee said that her computer died and then she'll be rejoining soon.
Okay. I'll keep an eye out for it. Thank you. So for number 12, I'm looking for 4 of a kinds. I only have a 1 of a kind now. So I'm going to multiply both the top and the bottom by the 4th root of x to the 3rd. So on top, I'm going to get 2x to the 3rd, 4th root of x to the 3rd. Extend the page. Over, this would have given me the 4th root of x to the 4th. The 4th root of x to the 4th is x. And then what you have to be cautious of, I have an x and an x on top and bottom, tug of war, top and bottom. So I'm going to reduce that one. Then I'm going to get 4th root of x to the 3rd. And this one would have canceled out because that would have been a 2. So that's our answer. There's no further we can go with that problem. We're not trying to decipher it any smaller.
Mrs. Europe,
Yes,
I have a question.
talk to me.
How did the square root of x to the 4th 4 become x to the 1st?
Okay, so think about this. If I had the square root of this, I would get this. Agree?
Yes.
Okay, so that'd be like saying the square root of 9 is equal to 3, right?
Yes.
If I have the 4th root of x to the 4th, x to the 4th is x, 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 and x. Okay, so I'm looking for a 4 of a kind. So basically, if I put this back in exponent form, it'd become x to the 4 over 4. 4 over 4 reduces to x to the 1st. X to the 1st is the same thing as x. And that's what we did on that problem.
Okay, thank you.
You got it. Any other questions? Moving right along. What time we got here? I don't even know. I'll just keep teaching till tomorrow. Woo! All right. Now it's starting to get goofy. So I have a base of 3, 3 raised to the 11/4, and 3 raised to the 1/4. So I'm going to go 11/4 minus 1/4. Okay, 11 minus 1 is 10. 10 over 4 is that, which reduces to 5 over 2. So this answer to this problem is 3 to the 5 over 2. And it's done. Okay. The second problem, I have a base of 5 and I have a base of 3. Okay. I can't go combine my bases. I can't add my exponents or subtract my exponents on that one because my bases aren't the same. So this problem is as simplified as you'll get right now. Okay. So there's no further I can go with that problem. 15. Oh boy. All right. So this is the 4th root. Agree? So 16. Oh, Will dropped out too. Admit. 16 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So the 4th root of 16 is 2. This becomes x to the 12/4, reduce 12/4, which becomes x to the 3rd. So that takes care of that. Then if I bring that down, I'm going to get y to the 8/4. Y to the 8/4 is y to the 2nd if I reduce the fraction. And then I get z to the negative 4 over 4, which is z to the negative 1. Being z was on bottom, it'll come up on top, and we're done with the problem now. Oh boy. That's all kinds of meat and potatoes with that problem. Good thing we're meeting together to be in class either tomorrow or Wednesday, depending upon which period I have, so we could actually see this. All right. So with this one, what you want to do is you want to turn the top into 3 to the 1/3 power. On bottom, you want to turn to 3 to the 1/4 power. Does everyone feel comfortable why I made it 1/3 on top and 1/4 on bottom? So I'm going to go 1/3 minus 1/4 because they're top and bottom. And so that's going to give me 4 minus 3 over 12. So that's going to give me 1/12. So that's going to give me 3 to the 1/12 power, and the problem's done. Yep, that works. 27 to the negative 1/3 power. This is going to be the same thing as 1 over 27 to the 1/3 power, which is the same thing as saying the 3rd root of 27. 3rd root of 27 is 3 times 3 is 9 times another 3 is 27. So the 3rd root of 27 is 3. So this answer is just 1/3. Then this one, I'm going to go y to the 2/3 on top, y to the 1/5 on bottom. I'm going to go 2/3, subtract 1/5. So I'm going to get to what, 10 minus 3 over 15. So that's 7 over 15. So that's y to the 7/15 power. Moving on. How much more do I got? Got that, Matt. All right, clear your schedules for the rest of the day. I'm just kidding. All right, so add or subtract the radicals. So being that this and this are the same thing, we can just go 5 minus 3 to get 2, and then I have 4th root of 7. It's done. I have x to the 2/3, x to the 2/3 are the same. So 4 minus 8 is, or 12 minus 8 is 4, x to the 2/3. That's all we have to do with those. So when we get to these, we need to start thinking about how we can start breaking them down. So I'm going to take this as a part. So I have x, and then I know I have x to the 6th times x to the 1st. Do you agree that x to the 6th and x to the 1st is x to the 7th? If so, that means the square root of this is x to the 3rd. So outside, I'm going to have x to the 4th times root x minus 4. And then I know that this is x to the 8th, x to the 1st. When I multiply, the square root of x to the 8 is x to the 4th. So I'm going to get minus 4 x to the 4th root x. These are the same now, so that's 1. So 1 minus 4 is negative 3 x to the 4th root x. And this is usually where you need to stop me and say, huh? And if you're saying that with your microphone on, I can't get the humor out of it. Okay. We good? All right. I'm going to distribute this in. 1/4 of 8 is 2. And then y to the 1/4. Plus, distribute this in. That's x squared. And then that's y to the 2 over 8. 2 over 8 is 1/4. That stays the same. I happen to have 2 of these, so now I wind up with 2x squared y to the 1/4, and the problem's done. This has got some serious stuff to it. I'm happy we're coming back to school tomorrow. All right. First thing I'll look at is this. I have 3rd root of that. So I know that the 3rd root of negative 8 times 2 is negative 16. And I still have this. I'm not changing anything to this one. The 3rd root of negative 8 is negative 2. So that's going to give me negative 6, 3rd root of 2, plus 2, 3rd root of 2. Negative 6 plus 2 is negative 4, 3rd root of 2. Problem's done. 24, I'm looking for perfect 4th roots. Perfect 4th roots. So 2, 4, 8, 16. So I know that this one's going to become fourth root of 16 times 3, which then becomes 2 fourth root of 3. And then I'll do this next one, 243. Let's see, 3 times 3 is 9, times 3 is 81, times 3. Oh, that's just fourth root of 243 is 3. Okay, because if I go 3 times 3 times 3 times 3, so I got 3 times 3 is 9, times 3 is 27. Oh, and I have one more. So 343 is 1, 2, 3, 4, 9, 27, 81 times 3. So there's one more 3 left over. Okay, so that's going to give me -9 fourth root of 3. And fortunate for us, there's nothing to go here. So now I have, these are all the same. So I'm going to go 2 minus 9 is -7. -7 plus 5 is -2. Fourth root of 3. Let's see who emailed. Oh, okay. And then last one. Hey, we're done. Yikes. Okay, I would bet you that there's at least one question that comes from tonight's homework for tomorrow or for Wednesday, whichever day you're in class. Agree? And some of you are going, Stirrup, it's Monday and you just blew us out of the water. I got you. All right, so I'm going to go into Algebra 2. And I'm going to go into this week. So I have 8C blank notes. 8C is what I just taught. 8C homework. I will make this due January 12th or 13th. Okay. Same rule applies, folks. If you spend more than 40 minutes on that, stop at that point. Okay, and just call it good. I'm giving you all benefit of doubt that you did A and B without me looking at them, so I'll put those in the grade book for you. But I will be checking off worksheet 8C tomorrow or on Wednesday. Now notice, I do have a quiz. Okay, this quiz, don't go in and do it yet. Okay, wait till I'm done after after Tuesday or Wednesday's lecture. You should be ready to do it at that point. Okay, so the only thing due tomorrow will be, or Wednesday, depending on which class period you're in or which cohort you're in, will be worksheet 8C. Good to go? Friends, that is, if you have any questions, stick with me. If you don't, get out of here. Have a great day. Take care of one another.
Thank you.
Thank you.
Thank you.
Bye, guys.
Thanks, Mr. Stewart.
Thanks.
Bye.
Thank you.
Thank you.
Stirrup.
Bye.
For cohort B, are we going to be upstairs or downstairs when we go back?
We'll be in our normal room.
Okay, thank you.
Yeah. Will, Costa, Annalee, you're all on still.